Hello everyone. Today we are going to discuss about double-ended queues deletion operation. So we know in double-ended queue, insertion and deletion both are possible at both the ends, that is front as well as at rear. So in previous videos we have discussed how we can perform insertion at front as well as at rear end. Now we are going to discuss about the deletion operation, how we can perform deletion at front as well as rear. So deletion at front end. So usually in a queue data structure we perform deletion at front only. We just increment the pointer by 1. So that is how the deletion happens in queue data structure using array. So the same thing is applicable here also. And before deleting any item from the queue, you have to check for the condition, that is underflow condition, because your queue should have something to delete. Else, if it is an empty queue, you cannot delete any item, right? For that case, we have to check with the underflow condition. How to check that underflow condition? How I can know that my queue is empty? With this pointer, that is front. If front and rear is equal to -1, I can say my queue is empty. Okay, so I have to check my front is equal to -1 or not. If it is equal to -1, I can say I must say this leads to underflow condition. We cannot perform deletion operation because your queue contains nothing. If the queue is not full, if the DQ has only, that is, you are going to perform your double-ended queue deletion operation. If your queue has only one element, say it has only one element, then I have to, if it has one element, which means if I'm going to delete that one element, what happens? My queue becomes empty. So at that situation, I have to set rear and front pointer to -1. If my queue contains only one element, I have to set rear and front pointer to -1. So that condition we have to set. And else, if front is at end, I have to make what? I have to set front is equal to 0 in this case for performing deletion operation. Let's see. If it has only one element, I am going to set my rear is equal to -1, front is equal to -1. Okay, else if front is at end, at last, I have to set front is equal to 0 in this condition, because I am going to delete at the front. So if my front pointer is here, okay, front pointer is here, then I have to make that after this point, after if I am going to delete any item if, in this position, obviously I have to make my front is equal to 0. Okay, and then, or else my front is somewhere here, I have to increment my pointer by 1. So in this case, my front is 0 only. It is pointing to 0th location only. So what I can do, I can increment my front pointer by 1. If I do that, my front points this element 3. Okay. So in that way, I can delete my front position element. And next is deleting an item at the rear end. So this is a different case. Before that, we have discussed deletion at the front end. So front end, it is obvious, like your queue data structure. We usually delete any item at the front end. Here we are going to perform deletion at the rear end. So here the same condition, if the queue is empty, I have to make front is equal to, I have to check whether my front pointer is -1 or not. If it is -1, it says it is an empty queue. So that I can say it is an underflow condition. I cannot perform any deletion operation. If it has only one element, the same thing. If I'm going to delete that one element also, I have to set my rear and front pointer to -1. So that is our second case. And if rear equal to 0, okay, rear is 0 means it is in the first location. Rear is at front, okay, first location. Then I have to make rear is equal to -1 because I'm going to delete at the rear end. So that I have to make rear equal to -1. That we will see diagrammatically. So here front is pointing 0, rear is pointing 1. I am going to delete at the rear end. So what I am doing, this is my rear pointer. So I am going to delete this 1. Okay, I am going to delete this one element 1. So if I do this deletion operation, what I have to do? I have to decrement my rear pointer. Rear equal to rear -1. I have to do decrement operation. Rear equal to rear -1. So my rear pointer will point to 1 instead of 2. Okay. So this way I can perform deletion in double-ended queue at rear position. So that's all about our insertion and deletion operation with the DQ. Thank you.